Hello guys, we meet again. Today I will be speaking about radio modules. As you can see, we have one radio transmitter and one radio receiver over here. So both of these modules uses 433 megahertz as its frequency. So we will be like exploring on the components and also how we can make use of it in our projects or any of our embedded designs. So before we go into detail, I would like to simply speak about why we would use radio communication. All right, so basically radio communication will be used because it's cheap and it's very much readily available. Right, so in most electronic stores, electronics, not electricals. All right, so if you go to like any electrical stores like Citron or any like retail shops that provide you with electrical components, uh, radio modules are very much available. Right, so it's easy to find and also it's very cheap. So I think both of this module would cost less than 10 ringgit in Malaysia. Right, so it's very cheap. And also another one point that I would like to stress is radio modules are very simple to use. Right, so if you have a project which requires you to achieve communication between two modules, then if you use radio modules, it will be very simple. Right, okay, so that's pretty much about why you can use uh, radio modules. Two reasons: it's cheap and it's very easy to use. Okay, so now let's move into the parts. Okay, as you can see, okay, these are the parts. Okay, again, excuse me for my shaky camera. My stand is a bit shaky, so it's always bouncing. Alright, so as you can see, there are 4 pins. One is VCC from the leftmost pin, and then ground, data, and ant basically stands for antenna. Alright, so this is how it look like once you purchase it. Alright, okay, now if you wish to get like better communication, you can always attach a single core wire like this. You can see there's a single core wire attached at the antenna. Right, so basically it extends, like it's as long as like 15 cm, so you can use a single core wire to simply get a better transmission. Right, so another one easy way of using radio modules, you can just simply use a single core wire and then you can attach it. It would work as an antenna. Right, okay, now let's move to the radio receiver. Right, okay, this is the receiver, and as you can see, it has 4 pins as well. Now let's explore what the pin is about. As you can see, okay, we have 4 pins. We have ground, which is the leftmost pin, and then we have 2 output pins. Don't know for what reason we have 2 output pins, but there is 2 and both is functional. Right, so, and you have 5-volt pin. Okay, let me put it this way so you can see it better. So we have 5-volt, we have output, and we have ground. Right, okay, so that's pretty much about radio transmitter and radio receiver. It's very basic. Okay, so right now what I'm going to do is I'm going to simply attach these two to an Arduino Nano and Arduino Uno, so that we can work on it. We can understand how to achieve connection through these modules. Okay, so right now over here I already have an Arduino Nano over here. Okay, if you can see. Alright, so basically what I have over here is ground, and I have ground and 5 volt, and over here I have D7. Okay, as you can see I have D7. So I'm basically using my ground pin and my 5 volt pin and my D7 digital 7 pin for my transmitter. Okay, so since the pins are already there, I'm going to just go ahead and attach it. Okay, I have, okay, this is how it should be. Nope, this is how. Okay, so you can see my orange color pin, which is my ground pin, is basically going to the ground pin, and my, what color is this, brown or gray, is 5 volts, so it's going to the VCC. Okay, you can see it's VCC, and my orange color jumper is going to the output. Okay, sorry, my yellow color jumper is going to the output because my yellow is digital 7, right? And okay, that's very basic. Okay, now let's move on to my Arduino Nano. My bad, Arduino Uno. Okay, so now we have 5 volt. We have 5 volt and we have ground, and over here we're using digital pin number 2. Okay, green is digital pin number 2, black is ground, and brown is 5 volt. So I'm gonna just attach it. Let's take my receiver, and there we go. Okay, so ground pin, you can see ground. My bad, it's the way around. Five volt is the, okay, this is how it should be. Okay, you can see, as I said, my black color jumper is the ground pin, right? So I'm going to just put it back in, and now I have my green cable, which is the digital 2. It just goes to the output, and the brown is, like we said earlier, is the 5 volt. Okay, so it's a very simple setup. This is how it both looks. I have the one end, I have my Arduino Nano, and on the other hand I have my Arduino Uno. Okay, now let's look at the coding and see how we can make use of the coding to transfer data, or like to basically establish a communication between these two models. Okay, let's take a look at the codes. So over here we have coding for transmitter. Basically we're going to have two sets of codes. One is for transmitter and another one is for receiver, of course. So basically, as you can see, I've included two libraries. One is RH_ask and another one is SPI. So RH is basically a radio head library. Alright, so having this library readily available makes things a whole lot easier for us. So we just have to use an existing command within the library, and then we can achieve a radio communication. Okay, without this library there would be like so much work and so much coding to do. So thanks a lot to whoever that created this. So before you can make use of this library, you need to ensure that you have downloaded this library, and this library is already available in your Arduino. Okay, so this you have to import it into your library. Okay, as you can see, I have my radio head already pasted, and those libraries and sample codes are available for use. Okay, so you need to make sure you have this, and then you can call the library. All right, So the next one would be SPI.H. So SPI.H basically stands for Serial Peripheral Interface. We don't have to know much about this, but one thing you need to know is that this ASK, Radiohead ASK and Serial Peripheral Interface both works together. So you need to have these two in order for Radiohead ASK command to work, right? So I'm not sure what the exact connection is, but I've tried not using SPI.H, but it doesn't work, right? So you just need to have these two in your codes before you can start compiling. Okay, so now moving on, this is basically Radiohead, and your radio name is just radio. Okay, and this is the speed, and this is the transmitter pin. Okay, so over here I don't think there's much use for us, so and therefore I have like put double inverted commas, so there's no value in it. I think this one stands for a receiver pin, and this one is for transmitter. Okay, so since this is a transmitter code, and we are only using a transmitter module, so that there's no need to configure these values. Okay, you just only have to configure the transmitter pin value. Okay, so moving on to the next one, void setup. So it's a one-time setup. Basically, pin, I'm just using this pin as an output to indicate whether my code is actually working or not. Alright, so this is to establish serial communication, and this is to initialize radio over here. Alright, so without initializing it, the radio wouldn't work. Alright, so I have this simple if coding over here, just in case if my radio failed to start up, then it would just simply throw initial IT fail, initialization failed. Okay, so next is void loop. Alright, so this obviously this code is going to be running in loops again and again. Okay, as you can see, I have written this code to transfer strings, of characters. So this is not a code to transfer integers. Alright, so integers or float or decimals. So there's another code for it. Probably I'll share it in another tutorial, but for now let's make use of this, so just to understand how we can transfer string from one transmitter module to another receiver module. Alright, so hopefully by knowing this, you can like transfer some important messages that you need to display on the other receiving end or the receiving module. Okay, so this is the code. So this line is basically the lines that is crucial. It's just readily available in the library, you just have to use it. So most often these lines are not interrupted, we just use it exactly as it is. Okay, so radio send UNIT8, I think it's basically stands for a byte of message, and this is the string length of the message. Alright, so it sends this message, a byte of this message, and according to this length. Alright, so basically it tells sends, my bad, let me retype that, sends a message with a certain length, right? So if you really want to know how this whole library works, you can always check it out at Radiohead website, and you can read through it. Alright, so I'm not going to be speaking much about it because it dives way too deep into radio communications and radio frequencies. Alright, so you can check that out in the library if you wish to do so. And then this one, radio wait packet send, is basically means wait until the packet is being sent. Alright, it's that simple. It's okay. So I have put these lines over here just to see if I can see in my serial communication that the message is appearing. That means I've basically successfully run this line, and this in a way this tells me that I've like successfully sent out this word or this string. Okay, so from my transmitter. So from a transmitter point of view, you can if you have like such lines and you can see your messages being displayed, then you can understand that your transmitter is working as it is. Probably the problem is somewhere else. Okay, this kind of helps a bit with the troubleshooting, right? And then after that I have digital write and digital low, so it's just gonna blink for about 100 milliseconds. I don't know if it's obvious on your end, but in my Arduino Nano I can see it. Okay, so that there is some reaction happening in the LED. So it's not just a basic, like always on LED. So it blinks to some extent. So when it blinks, it basically tells me that everything is successful, like transmitter is transmitting out the message, and our transmitter is good to go. Okay, so it's a very simple code when it comes to transmitter. Okay, so that's about it. Let's look at a receiver code then. Okay, let's take a look at the receiver code. Okay, as usual, we're gonna have Radiohead ask library, and then we're gonna have SPI.h library. Then, okay, please ignore these two lines. I was just trying out some codes, and these are the things that I've commented out. Okay, now the same line that we did earlier. We just need to configure the pins and the speed, right? So again, it is still 2000. I've tried like other than 2000, it's pretty much the same, and I really couldn't like notice the difference. Alright, so I've just maintained it 2000 for some optimal reasons. You can try out different speeds, probably depending on the radio modules that you have, and see how it works, and it affects the output of your radio receiver. Alright, and this is pin number 2, right? So pin number 2 is basically the output pin, which will be connected to the radio receiver, and then I've commented out, sorry, I've like put double apostrophe for the remaining parameters. Okay, so that's about it. The same void setup as we have seen earlier, and then moving into void loop. Okay, over here void loop is a bit different. Okay, so you're gonna have to look at it. Alright, so over here you can see byte buff. This is basically the lines in the these are the commands in the library, right? So you just have to use it. So this one is just asking for the maximum message size that can be supported by this library. Alright, so excuse me if my understanding is wrong, but to my knowledge this is what it means. So the maximum message size is now being set as buffer length, right? Buffer length. So that's what these two lines are telling us. Okay, now moving on to if a radio is receiving anything at this size, is receiving any byte of messages at this side, and it basically does the following. Alright, it performs the following instruction. So the following instructions would be, we have integer, and then we have string, and we have integer again. So I'll be explaining how do I make use of these three new variables. Alright, so I have integer j, and then incrementally it would increase by 1, and the maximum size is buffer length. Remember earlier we set buffer length as our maximum message size, so it would stop at that point. So every time it collects a character, and what it does, it adds to text. So text string incrementally collects all the characters, and then it performs like a string of letters. Alright, so once we have that, then we would simply display that in the serial monitor. Okay, so that's how the if function works. Okay, so now, and then if it's not capturing anything over here, then what it does is serial print. Okay, let me just change this is bad language, nothing received. So simply print nothing received, and digital write remain high always. Okay, while it as long as it's not receiving anything, it would remain high all the time. So that was it, what it basically means. Okay, that's the end, and these are the things of trying out. So there's no need to focus on this part. So our code basically ends here. Okay, so now let's try to upload these two and we see the result. Okay, now I have uploaded the code, so you can see code uploaded. See just now, so I've uploaded that, and okay, now everything seems fine. Okay, now let's look at the result. Okay, this is the result. I have maximized it, so we can see happy wall is coming in between nothing received. So okay, let me just uncheck auto scroll. You can see happy wall every here and there. Okay, so why this happen is because the message transmission takes place in a very short time period, so you can see in few milliseconds it's not basically capturing anything, but every now and then happy wall is appearing. Okay, so this is why this is happening, but you can see happy wall is always everywhere. All right, so it's always in between nothing received. Okay, probably the quality of the radio module is impacting this message, so it's probably the reason why the message is not fluid. We can see, like no signals received in between few milliseconds. Okay, either ways, the happy wall is there, like every I can say every second it is there. Okay, you can see 15 it's there, you can see 15 is there, 15 you can see 3 times in 15, and we can see 16 again, so every second it's there. So as long as you are displaying the result in an output device such as LCD or just any other like displayable output device, it shouldn't matter much, because you can always configure the code to only display in case if anything is received, and if nothing is received then let's not display that. Okay, so the reason why I've configured the code in such a manner is because I want to see what is exactly happening, and am I actually receiving the message or not, right? So that's pretty much about it. Okay, so anything else? I don't think there's anything else. Feel free to try out. Probably you can tweak the frequency and the speed to see how frequent this happy wall appears. Probably you can share your tips if you have any tricks to make your message more fluid and continuous. Okay, so good luck trying. In case if you have any questions, feel free to post it in the comment. I'll try my best to help you out. Thank you for watching.